Hello everyone. Thank you very much for your feedback and comments on our videos. Many of you asked us to provide solution of GATE question papers. So here we are with the solution of 2019 GATE paper. We are also going to upload more videos on this topic. So please subscribe to our channel and hit the bell icon for notification of upcoming videos. So let's start. So the first question is, what is the functionality of allyl alcohol for condensation reaction? To answer this question, we have to first understand what is functionality and then what is the relevant functionality for a specific reaction. So functionality of a molecule is defined by the number of functional groups present in the molecule which can participate in a chemical reaction. If we see the structure of allyl alcohol, we can easily identify two functional groups. One is unsaturated carbon-carbon double bond and another is hydroxyl group. But for condensation reaction, which is a reaction in which a small molecule is released during the reaction, the carbon-carbon double bond cannot participate in this reaction. So only functional group that can participate is hydroxyl group. So although allyl alcohol has two functional groups, but its functionality will be one for condensation reaction. So the answer for this question is B. So the next question is, which of the following polymers can be synthesized by ring opening polymerization? Ring opening polymerization is a form of addition polymerization or chain growth polymerization in which the terminal or end of a polymer chain attacks cyclic monomer to form a longer polymer. Therefore, we can answer this question by comparing the monomer structure of different polymers. Here, we can see that polyvinyl alcohol is synthesized from polyvinyl acetate. Nylon 6,6 is synthesized from adipic acid and hexamethylene diamine. And polyethylene terephthalate is synthesized via polymerization of ethylene glycol and terephthalic acid. At the same time, polycaprolactone is synthesized from caprolactone. Out of these monomers, only caprolactone is a cyclic monomer. Rest of the monomers are linear structure. Therefore, D is the correct answer for this question. The next question is, which one is weather resistant polymer? To answer this question, following information can be used. Basically, weathering performance of a polymer is measured by its ability to retain its physical properties and appearance when exposed to sunlight, ozone, high temperature, and moisture. The weathering performance of polymer depends upon following factors: chemical nature of the chain, source, like synthetic materials are much more resistant to weathering than natural polymers. It also depends upon level of unsaturation. Polymer chains containing less unsaturated bond are more resistant to weathering than polymer containing high amount of unsaturation. The relative weathering performance of different rubber is shown in this table. Based on all this information, it is very clear that silicone rubber is the most weather resistant polymer among the given option. So the answer to this question will be D. Question 4 is, what is the mechanism of polymerization if a combination of sodium and naphthalene initiate polymerization of styrene? To answer this question, let's first discuss different type of initiators used for different type of polymerization. For anionic polymerization, nucleophilic, and for cationic polymerization, electrophilic initiators are used. For free radical polymerization, radicals, and for olefin metathesis, organic metallic compounds and metal halides are used as initiator. In the given example, sodium reacts with naphthalene to form sodium naphthalide, which is a nucleophilic initiator. Thus, it will initiate anionic polymerization, and the answer to this question will be C. For more detailed information on this, please watch our video on anionic and cationic polymerization. Question 5 is, what is Hypelon? Hypelon is a trade name of chlorosulfonated polyethylene synthetic rubber. So the answer is A. The trade name of other chemicals mentioned in this question is given in the slide. It will be a good idea to memorize these common trade names. Question 6 is, among LDPE, HDPE and LLDPE, which one is copolymer? All three polymers are different form of ethylene. The major difference between them is their molecular architecture and composition. Among LDPE, HDPE and LLDPE, only LLDPE consists of ethylene monomer and long chain olefins. Both LDPE and HDPE consist of only ethylene monomers. So they fall in the category of homopolymers. Whereas LLDPE contains two different monomers, therefore LLDPE is only copolymer. So answer B is correct. Question 7 is, among the given polymers, which one lacks the ability to show tacticity? Tacticity is the relative alignment of side groups with respect to main chain. If all side groups are located on one side of the main chain, then it is called isotactic. And if every other side groups is aligned alternatively on the opposite side of the main chain, then it is called syndotactic. And if side groups are randomly arranged, then it is called atactic or heterotactic. One of the major requirements to show tacticity is to have at least one chiral center or an asymmetric carbon atom in the repeat unit. If we see the repeat units of the given polymers, we can see that only polyisobutylene does not contain chiral carbon. Therefore, polyisobutylene will not be able to show tacticity. Question 8 is, to arrange the given polymers on the basis of their glass transition temperature. It is good to memorize the glass transition temperature of common polymers. But if we need to figure out the relative glass transition temperature of different polymers, we need to first see the factors which influences the glass transition temperature of polymer. Glass transition temperature is a temperature at which segmental mobility of polymer starts. Different factors which influences the chain mobility are crystallinity, intermolecular forces, tacticity, molecular weight, degree of cross-linking, presence of additives, and chemical structure of polymer. Presence of big bulky side groups increases chain rigidity, thus also increases Tg. So, in the given example, PET and PC contains phenyl group which is rigid, thus their Tg must be higher than PE and PP. In case of PE and PP, PP contains methyl side group which increases chain rigidity, therefore PP will show higher Tg than PE. In case of PET and PC, PC contains two phenyl groups, thus it will show higher Tg than PET. So the sequence of these polymers in the decreasing order of Tg will be PC, PET, PP and PE. A is the correct answer. Question 9 is, which is the most economical manufacturing process for polystyrene cup? So, among the given option, The most economical method to manufacture polystyrene cup is thermoforming, and it will be good to memorize the most common method to produce widely available products like water bottle, chair, bucket, coffee cup, film, etc. But if you don't remember the exact process for a specific product, then following logic can be used to at least guess which product can be economically produced by which process. Products that can be produced by compression molding, as the name implies, the process is to prepare product by compressing material between two heated plates. So, chances that any kind of three-dimensional product that can be made by this process is very slim. So, if the product is two-dimensional and not extremely thin, then it can be made by compression molding. Because very thin products like packaging film, trash bag, can be economically manufactured by blow molding process. Injection molding is ideal manufacturing process to prepare three-dimensional product, usually product which are relatively small and thick. Example of most common injection molded products are bottle caps, car parts, toys, pocket combs, chair, tables, bucket, etc. Injection molded products are usually strong and used in load-bearing applications like chair and buckets. On the other hand, three-dimensional products which need not to have high strength can be prepared by thermoforming process like coffee cups, containers, lid, tray, etc. I hope this logic will help you in other similar questions. Question 10 is to match rubber additives with their function. Mostly, rubbers are mixed with different types of additives like curing agent, thermal stabilizers, colorant, processing aid to achieve the best performance. The common additives used in rubber compounding with their functions are listed here. Based on this information, we can match the additive with their function, and the correct answer is B. It will be good to memorize this table for other questions on this topic. Question 11 is to match polymer with their characteristic IR frequency. Each polymer contains characteristic functional group which show vibration at different frequencies. If you look at the structure of given polymers, polystyrene gives a peak around 3100 due to presence of vinyl group. Polyacrylonitrile contains nitrile group and it gives a peak around 2200 in IR spectrum. Whereas PET gives peak around 1725 due to presence of ester group, and polyvinyl alcohol gives peak around 3400 due to presence of hydroxyl group. So the correct answer is D. Question 12 is to match product with most suitable polymer. The relevant properties of the polymers mentioned in the question is listed here. Based on this information, it is clear that polyurethane is used for shoe sole application because of its lightweight, durable, and waterproof properties. Polymethyl methacrylate is used for optical lenses because of its good optical properties and compatibility with human tissue. Whereas cross-linked polyethylene is used in electrical cable due to its insulating properties and good weather, heat, and chemical resistance. Phenol formaldehyde resin is used to make electrical switches due to its structural stability and insulating properties. So the correct answer is B. Question 13 is to arrange polymers based on their limiting oxygen index value. The limiting oxygen index is a method to determine the flammability of the polymer. Flammability of plastics depends on the nature of carbon and hydrogen atom in the polymer chain. It also depends upon the presence of other atoms like halogen atoms, aromatic compounds. The typical LOI values of polymers are listed here. Based on this information, the correct answer is C. Question 14 is to match plastic additives with their function. Polymer are mixed with different additives to achieve desired processability and performance. Heat stabilizers are used to protect polymer during compounding at high temperature. UV stabilizers are used to enhance the weathering performance of polymer so that it can last longer under the sun. Anti-static agents are used to enhance conductivity and minimize charge buildup on the surface. And solid lubricants are used to minimize friction during processing and fabrication. Examples of additives used to achieve this function is listed in the table. Based on this information, the correct answer is D. In question 15, we have to identify different blends and composites. Before answering this question, let's first discuss what is miscible, immiscible, and compatibilized blend, and also what is composite. Polymer blend is a combination of two or more polymers which are physically mixed to obtain a new material, whereas a composite is a multi-phase material prepared by mixing a polymer with other material or reinforcing filler having different physical and chemical properties. These reinforcing materials can be clay, minerals, fiber, particles, etc. In case of blend, if the two or more polymers mix together very well and form a single phase indicated by single glass transition temperature, then the blend is known as miscible blend. If they do not form a single phase indicated by separate glass transition temperatures, it is called immiscible blends. In case of immiscible blend, when a small additive is used to enhance the compatibility between two or more polymers, then it is called compatibilized blend and additive is called compatibilizer. In the given example, it is very clear that mixture of PDMS and fumed silica is an example of composite, and blend of nylon 6 and PP is a compatibilized blend since malic anhydride grafted PP is a compatibilizer. Now between option 3 and 4, the miscible blend is mixture of polystyrene and PPO because these polymers have very strong compatibility due to phenyl group. Although PE and PP belongs to similar class of polymer, it forms immiscible blend because of very different molecular architecture. PE contains no side group whereas PP contains methyl side group. Based on this information, the correct answer is A.